Hello everyone, welcome back to class. Today we'll be looking at a very important topic in physics, which is directly from electric potential. Please, this is the best academy. If you know you have not subscribed to this channel, please try and do so. And please, distance yourself from distraction. Don't allow anything to distract you. And please don't skip any part of this video. Watch the video from the beginning to the end in order to get the full explanation and the full details of everything we are going to be doing here. We are here to guide you. Please move at our pace. Don't skip any part of the video. So let's move to the question we have for today, which is the electric potential V at any point S, Y, Z or in meters in space is given by V is equals to 4S squared volts. The electric field at the point 1, 0, 2 in volt per meter is dash. That is the question. Now, how are we going to solve this question? Given that electric potential V is equals to 4S squared, which is from the question, then electric field is the negative derivative of electric potential with respect to distance. Take note of that. When you differentiate electric potential with respect to distance, you are going to have electric field. But this electric potential now is given at any point in space, which can either be in the S, Y, or Z direction. Now, if you have your potential given in S, Y, Z direction, the electric field will be the negative derivative of potential with respect to X, and potential with respect to Y, and the potential with respect to Z, denoting each of the derivative with their respective direction. Remember, the S direction is I, the Y direction is G, the Z direction is what? K. If you can still remember that. So, but this particular electric potential now is towards, is just a function of X axis. That means this one is moving along the S axis only, because there's no Y here, there's no Z here. So only this first derivative will be functional here. But I'm just putting this here for clarification purpose. In case you have electric potential that is having both X, Y, and Z, this is how to differentiate it. Remember, we have brackets here. If you open this bracket with minus, the minus will affect this, this, and this. Don't forget that. So what is V? V is 4S squared. So if I differentiate 4S squared with respect to X, I'll put I there. If I differentiate with respect to Y, put G there. Differentiate with respect to Z, I put K there. Now, this operation, part of derivation, is called partial derivative or partial differentiation, in the sense that you differentiate V partially with respect to S. This means if you are differentiating with respect to X, all other terms will be constant. If you are differentiating with respect to Y, all other terms will be constant. If you are differentiating with respect to Z, only Z will become the variable, but other terms will become constant. That is the meaning of this derivative, type of derivative you are seeing, which is this D. Please take note of that. But the derivative is still the same thing as the normal differentiation, but when you are differentiating a particular variable, other variables will be taken as a constant. Take note of that. It's very, very important. So this we are going to have. For differentiate V. V is 4S squared. So put 4S squared here, put 4S squared here, put 4S squared here. After that, we're going to have this. Then let's differentiate each of them now to see what we're going to have. Now, if you differentiate this 4S squared with respect to X, you're going to have 2 times 4, 2 minus 1. That'll give us 8S for this. The differentiation with respect to Y, there's no Y in this place. There's no Y here. That will be 0. Differentiate this one with respect to Z. There's no Z in this place. So if there's no Z, there, it means this will become a constant. So if you differentiate the constant, it will be what? 0. That's what you're going to have. So let's move to the next. Let's see what I'm going to have. All right, differentiate the first one. We're going to have 8s. I've already said that I plus 0j because there is no y in the question. So differentiate 4s related to y will be 0 because there's no y in the question. Then because that v is not a function of y, that's what I'm trying to say. Then it's not a function of z as well. So if you differentiate related to z, it will be 0. Then at 1, 0, 2, it means the first one belongs to x, second one belongs to y, third one belongs to s. That is the meaning of this. This is how you state points in space from coordinate geometry. So that means s is equal to 1, y is equal to 0, z is equal to 2. 1, 0, 2. S, y, z, something like that. So anywhere you see s, you just put 1. There's no y, there's no z. Forget about that. We're going to have minus 8 times 1, I. We're going to have 8i. So this means the electric field is 8 in magnitude, but moving in the negative s direction. Moving along what? The negative s direction. And the unit is in either Newton per Coulomb or volt per meter. The unit is either Newton per Coulomb or volt per meter. So the electric field is either in Newton per Coulomb or volt per meter. So this is minus 8i in volt. Let me just put in volt per meters. In volt per meter. That's what I'm going to have. Minus 8i in volt per meters. Or you can as well solve it this other way. Now you can also solve the above question this way. V is equal to 4s squared. Now if you look at that, there's no y, there's no z in the question. You just have only one variable, which is x, or only one variable, which is arrow, only one variable, which is and z, or others. What you have to do, differentiate only with respect with that to that variable and impute the points. You're already good to go. This question already said v is equal to 4s squared. There's no need of differentiating related to y or z again. There's no need for that. Then e to the s direction will be equal to minus dv over dx. So you differentiate this one. Remember we did differentiation before. You can also check our channel for differentiation of polynomial functions. You're going to have, remember this minus is from with the formula from the derivative of this equation. So the minus is with it. It's not from the question. So the equation, the formula is es is equals to minus dv over ds. If it is e arrow, to be minus dv over the arrow. I already explained that when I was doing electric potential here. Then that will be equal to minus. Then if you differentiate this, it's not that if you differentiate this, there will be a negative sign. No, this negative sign, which is from the derivative, that is what we have in there. But this one, which is dv over ds, that is the differentiation there, not this minus. This minus is not from differentiation. The differentiation here is dv over dx. So the dv over ds will be 2 times 4, which is the power times the coefficient. 2 times 4. Then s raised to power 2 minus 1. Use the power to multiply the coefficient and remove 1 from the power. Then you're going to have something like 8s. This minus will still be with it. Then at s equals to 1, which is from the question, you have minus 8 as the answer. So that is, it is 8 along the negative s, as the remainder is moving in the s direction. That will be the answer to that. Thank you.